Hello and welcome guys. So in the last video we have completed our model training. So if you are new to this video, then please watch this playlist from beginning. So what we have done so far, first we have seen the visualization of our audio file, and then we have splitted those audio file into chunks, and also we have seen the visualization of that. Then we have converted those audio file into spectrogram, and we have seen the visualization. So we came up to the conclusion that it's very hard to put all the features of the audio file in a single graph. Like if we use this, then our model accuracy will definitely suffer. So to improve our model performance, what we have done, we have splitted those audio file into chunks, and then we came to the conclusion that instead of putting all the feature in a single graph, what we will do, we will split those audio file into small chunks, and we will convert those chunks audio files into spectrogram, and we will feed that feature spectrogram, which is our feature, to our neural network, and we will perform our training to improve our model performance. Okay, so that's why we have splitted this, and we have created the spectrogram for this entire chunk. So this experiment we have done for single audio file. So to generalize this entire thing, we have constructed one load and pre-process data function, which will take this data directory, which is our data set, and the classes exist in that data directory, and the target shape. This target shape is the shape of the feature vector which we want from this function. Okay, so this function will return and give us this feature vector, which is of shape 150 cross 150, and its corresponding labels. Okay, so we have triggered this function, and we got this much of training examples present in this data set, and this many corresponding labels are there. So we have used this labels and features, and we have splitted our data into training set and test set, and then we have constructed this model architecture, and we perform the training of the model. So after 30 epochs, we are getting 97.29% of training accuracy, and validation accuracy we are getting as 89.25%. Somewhere we are also getting 90%, but here we have not used early stopping. So after 30 epochs, we are getting this much, which is also good. It's close to 90%. Okay, and then we have saved this model. So up to here we have performed in this video. So now what we are going to see here in this video, we are going to perform the model evaluation, and we are going to see our model performance on this data set on different metrics, and also we are going to do a visualization so that we can see the variation and performance of our model with respect to each epochs. Okay, so this is what we are going to perform in this video. Okay, so first, to perform our model evaluation, we need two things. As I am running this project after a long time, so definitely I will lose all these things. I will lose this variable. So if I write here directly as model, so it will say me to that name model is not defined. Why it's saying? Because I don't have my kernel doesn't have this model variable information. Okay, so I have to recover this model model variable and this training history variable. So that's why we have saved this model in the form of h5 file, and this training history in JSON file, so that if in future we need it, then we can reload it. Okay, so I will also show you here how we can recover these two variables which we have saved earlier. And but before this, we also need this thing, this x train y train. Okay, we also need this x train y train, x test y test. Okay, so to recover it, we have to reload this function, we have to run this function, and we have to take this data and labels, and then we have to perform splitting. So for this part we have to rerun it, because we doesn't save this information. We can also save this information by using np.save. There is one command. If you go here, p.save, if you do, I think, yeah, this thing you can use to save numpy array in the form of npy file. Okay, so if you see the documentation of here, so by using this np.save, you can save this array, okay, in the form of npy file, and you can also reload it by using np.load, and you have to give the file name like here test.npy file. Okay, so if you do this, then you can save your numpy file also. So but we have not done that in this project. Okay, so we will reload it. Okay, so before that we have to rerun this importing library part. So we have successfully imported our library. We will not run this thing because this is a part of experiment which we have done in our previous videos. Okay, just to show you, just to make you understand the entire thing, how things are happening here. Okay, so this we will not run, we will run from here, data pre-processing final. Okay, so we have successfully reloaded our data directory and classes. Now we will run this load and pre-process data function. So it will take our data directory and classes. Okay, so I'm running it. So it will take some time, it will pre-process all the classes. We are iterating for each classes. So first we are iterating over blues, then we will iterate over other classes also. Okay, and one more thing, if you are if you're watching this video directly after this model training, then definitely you have this model access and this training history access. Okay, if you have this two variable access, then you can continue this thing. You don't have to rerun and follow this procedure what we are doing right now. Okay, this is just I'm showing for them who are who have trained this model and done up to here, who have saved this history and model by watching the last video, but they are doing this thing, they are performing model evaluation later, and they don't have, they lost this model variable and training history variable. Sometimes kernel also died, so they are starting from scratch. So they have done up to here, but after some time and after some days they have closed this entire thing and they are starting from here. So for those who they have to follow this thing. Okay, they have to follow like this, whatever I am following here. Okay, so right now processing of 3 classes is completed, like 2 classes is completed and third is happening right now. Okay, so we have completed our pre-processing, load and pre-processing function is completed. Now let's run this. Okay, so same we will get here. So we have to recover this variable. So we got our variable xtrain and xtest. Okay, so now we don't have to run this building model part and model training part because we have our model saved and training history saved in this file. Okay, so now if I run here, xtrain, if I execute this, then I will get all my metrics. Okay, same for xtest and all. Okay, I will get everything. Now we need these 2 variable. Okay, so for reloading I will write here reloading model variable. So for reloading, what we will do, we will use tensorflow. We have imported here tensorflow, right? Yeah, tf, tensorflow as tf we have done. Okay, so I will use here tf dot keras dot model dot load model. I think no, it's models dot load model. Okay, yeah, tf dot keras dot models dot load model, and here I will pass my this thing training model dot h5 for keras. You can pass anything. Okay, so I'm passing here because my PC support h5 and keras both. I think it will optimize that keras file format. Okay, model dot summary, if I do here, then I will get my model. So yeah, see, same thing I will get 27.4 MB, whatever we have constructed here earlier, the same thing we have got it from here. Okay, so this model I got. Okay, now we have to load this part. So for that we have to import our JSON. Okay, and we have to use with open, and here we have to give this thing. Yeah, this thing we have to give this file, and we have to give here with open this. Okay, and mode I am giving as like here we have given write, so here I will give as read. Okay, and I will write here as JSON underscore file I will write. Okay, and inside this I have to write here data, or we can write here directly training history we can write. Okay, this thing, training history is equal to, we have to use json dot load, and here I have to pass this json file, this thing. Okay, that's it we have to do. And now if I write like this training history, then I will get this entire thing. Okay, this is a dictionary, and if I do here dot keys, I will get all the keys, loss, accuracy. This is our training loss, this is our training accuracy, this is our validation loss, and this is our validation accuracy. So we recovered our training history and also this model and this X train, Y train, everything. Okay, now we are ready for model evaluation. So here I am writing here reloading history, training history. This is a way you can reload your training history. Okay, now we are ready for model evaluation. So I will give here markdown as model evaluation. Okay, so to do model evaluation, first we will do model evaluation on training set. So I will write here model evaluation on training set. Okay, and I will write here model dot evaluate is their function. Yeah, this one, model dot evaluate, and in this what we have to do, we have to pass our X train, Y train. So X train I will pass and Y train I will pass this thing. Okay, see, that's it. And this thing will return and give training accuracy. So we have to write here train accuracy. Okay, basically it will return and give us two things, training accuracy and loss. So like second thing will be training loss. First let me see the documentation. I think first one is model dot evaluate. If you are confused somewhere, then you can go and watch from here. Model dot evaluate, if you write here keras, then you will get here things. Yeah, this is a model dot compile, and somewhere we will also get this model dot fit, and this is model dot evaluate. So it will return and give us loss value and matrix value. Okay, first it will give loss and then it will give accuracy. Okay, so first it will give us loss and second one will be matrix value, which is our accuracy. So I will write here train loss here, train underscore loss comma train accuracy. It will give two things. Okay, so let's run this. It's running. So we'll write same for model evaluation on validation set, model evaluation on validation set, and same we'll do here. We will write val loss comma val accuracy, and we'll write same thing model dot evaluate, and in this will pass our X test and Y test. Yeah, let's run this also. So if I print here this thing and also this thing, so you will get this much of loss we are getting 0.04 and accuracy we are getting 98.5%. Okay, so we have also completed this. So let's see the what we are getting. So this much of 0.47 validation loss we are getting, and validation accuracy we are getting as 89.2824%. Okay, so by doing this we can do the model evaluation and we'll get our result. Okay, now what we will do, we will write here and we will do the accuracy and loss visualization. Okay, here we'll give a markdown as accuracy and loss visualization. So first we have to write epochs, how many epochs we are using. So we are using 30 epochs, so we have to create one list, a list from 1 to 30. So to create a list, I am using the technique of list comprehension, and I am writing here this I, and for I in range of 1 to 31 I am giving, so that I can get the list of 1 to 30. Using this we can append, we are iterating over each element of this range which is from 1 to 30, and we are appending those elements in this list. To write that logic we can write in one line in Python by using this technique is called list comprehension. You can use this thing, and if you print the epoch then you will get this list in which you will get elements from 1 to 30. Okay, so this thing we want. Okay, so we got our epochs. Now what we will do, we will plot it. Okay, So we'll use here plt.plot, and first parameter will be x-axis, which is our epochs, and second parameter will be the training history loss function. Okay, to see that we can write here training history. I think in training history we have that, yeah, because right now we are using this variable, this training history we are using, we are reloading directly from JSON, we are not using this one. Okay, if you are using this one, then you have to write this training history dot history. Okay, but like we are reloading from our JSON, so this is our variable right now. Okay, or we can change it with this thing, training history data, so that you don't get confused. Okay, so I am writing here training history dot data. This is different. Okay, so training history dot data. So what we have to do, so here we have to write this training history dot data underscore data. So this is our training history data. So we have to pass here training history data. Training history data we have to pass. Okay, and so we are going to plot, first graph will be of training loss, so we have to extract the loss. Okay, so to extract the loss, if we write like this, then we'll get it. This is all about training loss. Okay, so to write here training loss, we have to write like this, and label I'm giving as label is equal to this is our training loss. Okay, if I do here plt dot show, then I will get it. So this is our training loss. Okay, now second thing what we need validation loss also, to compare that what is the, with respect to each epoch, what is the variation of training loss and validation loss. Okay, here I am also giving a comment as visualization of loss. Okay, so same we have to perform for validation loss. So I will give here this thing plt.plot, epochs we will pass, and second parameter we will pass as if I show you this for validation loss, we have to use this key. Okay, if I put here like this, then you will get this list of validation loss. So we have to change it with this. Okay, because this dictionary contain loss accuracy, validation loss, and validation accuracy. So we have to write here like this, and we have to change it with this validation loss. So if I plot this, then you will get like this. So this one is validation loss, and this one is your training loss. So we can give here color also, so that we can differentiate what this line is. So I am giving here color as red, so that our this red one will be training loss, and here also I am giving color as blue I am giving. Okay, if I run this, then you will get red one is training loss and blue one is validation loss. And to show in the graph, because we have to see the code to understand that which one is training loss, which one is validation loss. So to do that, we will write here plt.legend, so that we can identify which line represent what. So if we do plt.legend, then you will get this thing. What it's doing, it's exactly picking the it's taking this color and it's mapping with the label, what label we have written. Okay, if I write here xyz, and if I run this, then it will pick this label for this color. Okay, so that's why we have done this thing. Okay, so it's picking this label and corresponding color, and it's mapping and showing in the graph. This is the function of, this is the work of this plt.legend. Okay, now we have to define x label and y label also. We don't know what is this x axis and y axis. So I am writing here plt.x label, and this x axis denotes the number of epochs, and this for y axis we'll use plt.y label, and this y axis will represent, we can write here simply loss. Okay, this is our loss, and yeah, title will be visualization of loss result, visualization of loss result, what we are getting earlier. Okay, if I run this, then you will get this thing, visualization of loss result, and this is red one is training loss, and this one is validation loss. Okay, so this is what we are getting. So same we have to repeat for accuracy also. So I'm copying this information here. Okay, and I will change it with accuracy. Now we'll see the visualization of accuracy. So instead, in place of this, we'll replace it with accuracy. Okay, so this will be the visualization of accuracy result, and epochs will be same, and this thing will change with this this accuracy. This accuracy is basically the training accuracy. Okay, so we'll change with this, and validation accuracy will be replaced by val accuracy. So I will write here val accuracy, that's it. Okay, and here also we have to replace this thing. So loss will be validation training loss, and validation loss will become validation accuracy. Red blue same. Okay, number of this, and y-axis will become now accuracy. Okay, if I run this, then you will get this. So this red one is training accuracy, and this blue one is validation accuracy. And if you remove this color also, then also it will work. Okay, plt.legend will work then also. So by default color it's picking, and it's giving, like, it's mapping it with whatever color is for this one, and this is for training accuracy, and this is for validation accuracy. So you can do like that also, no issue. Or you can write here color, you can give here color also, then also fine. Okay, so this is the visualization of our loss and accuracy with respect to each epochs. Okay, with respect to 1 to 30, whatever epoch. Okay, so you can see the performance of your model, like how your model is performing on each epochs. So if you see here, after this 5 epochs, it's like it's improving rapidly up to this 5 epoch. That's validation accuracy. And after this 5 epochs, it's it's taking time to improve its parameter. Okay, and after 20 epochs, it's almost at same. Okay, fluctuation is there, some fluctuation is there. And for training accuracy, after this 20 epochs, it's like almost similar. Okay, some slight variation is there. Okay, almost it's straight. And what is the performance of our model on loss? So this is loss. After 20 epochs, it's almost straight. The same thing, whatever we are getting for accuracy, we are getting same for this loss also. But in this validation loss, we are seeing the fluctuation. After 20 epochs also, it's fluctuating, but it's in range of this 0.5 to 0.75. It's in range of that, and sometimes it's less than 0.5 also. Okay, so this is what we are getting on this model. If you want to improve more this model, so that you can get more smoother curve here, you are getting some fluctuation, so you want this more smooth, then you have to tune these parameters. You have to make your architecture more powerful, and or you can improve your model architecture, or you can increase the target shape, or you can tune this chunk duration, overlap duration, like 5 second or 6 to 6 second, 6 to 2 second, or 6 to 3 second. You can do like that. You have to do experiment, and you have to do pre-processing, and then you have to check whether this architecture is working on that structure of data set or not. And based on that, you have to tune these 2-3 parameters, and then you have to train your model, and you have to see the performance of your model from here. Okay, by plotting the curve, you can get the performance that you can compare with this result, and you can tune your model, and you can see that whether you are improving your model or not. Okay, so do these experiment, and if you are getting more better result as compared to this, then you can post in the comment box, and you can tell me that I'm getting good result on this parameter value, and on this architecture. Okay, you can put in the comments so that everyone can understand and learn these things. And it's a great learning for me also. Like, if you came up with some other approach or something else, it's a great learning. Okay, so I think we have done lots of things here, and so that's all for this video. We'll meet in next video, and in next video we'll calculate the precision recall and confusion matrix for this deep learning model. Okay, so that will be the final model evaluation which we will perform for this project, and then we will move towards model testing, and we will do the model testing on some random audio files. And once thing is finished, then we'll build a small web application for this, interactive web application, which will take audio files and it will give you prediction in which class it belongs, like which genre of music it is. Okay, so we will compute that and we will close up this entire thing. Okay, once we finish our web application. Okay, so I think that's all for this video. Thank you guys, thanks a lot for watching this video. We will meet in next video.